Welcome to Laboratorium Matematika Indonesia Collaborative Research and Project Initiative 2020. My name is Andonowati. I'm from Laboratorium Matematika Indonesia. First initiation of this collaborative research is in the area of ocean and coastal engineering. The aim of this initiation is to investigate possibilities for executing high-quality research and projects in the area of ocean and coastal engineering that may become a model for other topics. Each cluster of this initiative consists of several activities. The first activity is lectures from companies or industries, government, and university research institute. This activity will be followed by interviews with representatives of the policymaker from industry and government. Each cluster will end with physical or in this time of pandemic, online networking meeting to seek possible collaborative research and project. I would like to announce that the first cluster is in ocean engineering, and I would like to welcome Professor Brenny van Grussen from Laboratorium Matematika Indonesia to please give the welcoming remark.
Thank you very much, Ibu Andonowati, for your opening remarks. And let me go into some detail about the contents. Coastal countries, and in particular Indonesia as the largest archipelago, can profit economically from the surrounding seas and ocean. You can think of fishery, transportation, tourist destination, and when available, oil and gas. More and more, nowadays, also the sea is used as an area for large wind farms. The price to pay is that we have to protect from flooding, especially in this time of sea level rise, and in countries like Indonesia, protection for tsunamis. Our institute, LabMath-Indonesia, has been doing research in coastal and ocean engineering for the past 15 years, in particular, development of software. But the problems and the opportunities are still huge, and further collaboration with partners is very much welcomed. The problems are too huge to be done by only one or a few institutions. This initiation as a platform for collaboration aims to get that collaboration. We thank very much the funding from the Dutch research organization NWO that may be known by many Indonesian scientists from the decades-long collaboration, scientific collaboration between the Netherlands and Indonesia. But most of all, we thank the lecturers who took a lot of effort and time to prepare their lectures that, to my opinion, are quite impressive. You will hear topics like about the shipbuilding, risk analysis, new ideas about tsunami, early warning systems, and even cities in seas or underwater railroad. I give back the floor to Ibu Andonowati to announce the first lecture.
I would like to welcome the President Director of PT PAL, Dr. Budiman Saleh, who will present the first lecture on the PT PAL capabilities in shipbuilding and energy industry. Please enjoy the first presentation.
Good morning, everybody. Let me introduce myself. My name is Budiman Saleh, President Director of PTPAL since 2017. PTPAL is the largest shipyard in Indonesia. I would like to express my sincere appreciation to LabMath-Indo, specifically to Bu Andono, for giving me a time slot in Wave Ship Oil and Gas session that would allow me to introduce myself, my company, our products, main activities, that what we are up to, and any possible collaboration with local as well as international institutions. Next lagi. We are located in Surabaya, East Java, for all the main activities of the company. We occupy around 150 hectares of land with access to the waterline and sea. We employ around 1,618 employees. We also have a rep office in Jakarta, basically for commercial activities. From these pictures, you can see the layout of the facilities, including the merchant and naval vessel, maintenance, repair, overhaul, general engineering, and submarine facilities. Next. Our product portfolios generally consist of new shipbuilding for both merchant and naval vessel, submarine for new building and maintenance, repair, and overhaul, maintenance and repair, overhaul, general engineering for the electrification and oil and gas activities, technology development, just like any engineering company should be. Next. This slide basically depicts all the products that we are proud of. This is not an overnight achievement, but rather this requires focus and ability to adapt to the changes. Being a company from a developing country, we are proud that we have delivered 282 units of general engineering products, as well as 232 units of vessel or ship for various applications. For general engineering, we are very much focused in electrification and oil and gas business. For ship, we are focused in all 60 meters naval vessel and underwater surface. We produce 60 meters offshore patrol vessel with missile, 105-meter frigate with missile, landing platform dock LPD or SSV for expeditionary force, as well as hospital ship. Last but not least, our baby submarine project. Next slide. These are our customers around the world. Quality, cost, delivery time plays an important role. Like any big and modern shipyard, we made lots of investment in facility for manufacturing the blocks, integrating the blocks, loading and unloading, floating, secure, environmentally controlled warehouse, laser tracker, and other test benches for all navigation, communication, sensors, and weapons. Next slide. We send our employees to various partners around the world for its uniqueness, for the defense and non-defense purposes. The names might be familiar for all the audience, such as Lursen, Daman, Daewoo, Mitsui, Meyer, Mitsubishi, and many others. Next slide. We are an integrated IT company for every process or activity. We use all the best engineering softwares available in the market and make them integrated through our IT systems. Next. In order to cut down the production time, increase the quality, reduce the cost, we utilize the modular construction concepts such that all the big blocks are manufactured and equipped with the components, piping, hosing, electronics, and many others. Every function test is carried out for every module. Once all the modules are finished, the integration is made much easier, just like playing or building Lego blocks. Next. The slide explains that we usually start the project using multi-starting points. In this picture, we have 6 starting points, concurrently to improve the production time, quality, and the cost. Next slide. As a wrap-up to all the requirements and achievements, this slide shows all the mandatory certificates that we have, including the awards and intellectual property rights for our products. Next. Next. Relaying using local resources as well as foreign partners, we developed our famous 57-meter fast patrol boat. Soon it was followed by our indigenous design 60-meter kapal cepat rudal offshore patrol vessel, which is equipped with top-of-the-line missiles and sensors. We work together with hydrology labs from Indonesia as well as from abroad in order to improve the design and performance of the vessels. For the support ship, we are proud in producing various types of landing platform docks for expeditionary operations, catastrophic evacuation, hospital ship, submarine tender for charging the battery, supplying water, distilled water fuel, loading and unloading the torpedo and missile, and many other purposes. Next slide. Since I took the office, we were pretty much focusing on defense and energy sectors. For energy, electrification is the most important target all over Indonesia. We are an archipelagic country. Electricity is still scarce in some remote islands. Barge-mounted power plant, hopefully, is our solution for Indonesia Power and PLN, State Electricity Company. We master in the ship technology design, manufacturing, and integration of the power plant itself. Our collaboration with the top engine makers in the world is always welcome. Barge-mounted power plant can run on dual fuel engine, gas, and liquid fuel oil. In the future, barge-mounted power plant can run on thorium, which are abundant in Indonesia. Next slide. Again, being in archipelagic country, distribution of LNG for remote islands, tourist destination, and many others have to be planned carefully. We propose a relatively small LNG carriers up to 20,000 metric tons carriers. We master in shipbuilding technology, but we need to establish a solid collaboration with companies who own LNG tank technology. With this collaboration, we can capture the Indonesian captive market. Next slide. Thorium is abundant in Indonesia, even more than uranium deposits, and safer than uranium. Together with Thorcon International, PTPAL performed the feasibility study for design construction, reliability study, and site study. Next slide. Sea wave and tidal as the renewable energy are the new topic in PTPAL right now. The basic idea is that we should cultivate what we have abundant in Indonesia and what technology PTPAL is mastering in producing a reliable source of sea wave power plant and tidal energy. Of course, collaboration with partners who own the technology is a must. Next. Next. I selected few feature products that we are focusing as our own businesses at this moment. First, barge-mounted power plant can be a propel or non-propel, can be deployed to any remote area, no electricity. can be deployed to any catastrophic damage area, and many others. Next slide. We are also active in offshore and onshore platforms for oil and gas application. Typical scope of works done so far is listed in this slide for your perusal. Next slide. Being an archipelagic country and in the Ring of Fire, we are proud of our hospital ship. Yesterday, in fact, we did the first steel cutting of the second hospital ship. The hospital ship can perform all the activities, including nuclear and biological chemical threat. The hospital ship can also serve as a mini airport where helicopters can land and take off. Next slide. For expeditionary force or operation, mass rapid evacuation, catastrophic evacuation, we produce our famous landing platform docks. Indonesian Navy and Philippine Navy were using this LPD during the Pacific Rim Pact exercise with at least 60 other countries around the world. Next slide. To safeguarding and patrolling our borders, we are proud to produce our Kapal Cepat Rudal or KCR or Offshore Patrol Vessel OPV equipped with top-of-the-line sensories and weaponaries. Now, we are focusing in designing and manufacturing a bigger frigate, 138-meter frigate that will be able to cover the open sea. Next slide. This submarine is our new project. This submarine was launched at the end of March 2019. Since then, the submarine had endured many tests, such as 116 tests out of 119 harbor acceptance tests and 40 tests out of 53 sea acceptance tests. Generally speaking, at this moment, around 97% completion. We are expecting to deliver the submarine to Indonesian Navy by the end of December 2020. In the picture, you can see it's a very rare opportunity to participate in the production as well as in the tests. For example, nominal diving tests at 250 meters and technical diving tests at 300 meters. In such, all the functions of our first submarine can perform well under such extreme conditions at those depths. I hope my short presentation will be sufficient for the audiences to initiate the interest for further discussion. We welcome any possible collaboration with any technology holders or owners, as explained earlier in this presentation. Thank you very much. Makasih.
For the second lecture, we stay in Surabaya and go to the hydrodynamic laboratory in Surabaya with a lecture from Dr. Erwandi. The precise title of his lecture is The Research Status in Center of Technology for Maritime Industrial Engineering. The floor is for Dr. Erwandi.
Hello everybody, my name is Erwandi. I work at Technology Center of Maritime Industrial Engineering Agency for the Assessment and Application of Technology, that well known as BPPT. Right now, I station in Indonesian Hydrodynamic Laboratory in Surabaya, Indonesia. I would like to thank to Madam Dr. Andonowati from LabMath-Indonesia, Bandung, who invited me to give this short presentation about my institution, the main activities of my laboratory, current research, and possibility to make research collaboration. My presentation entitled The Research Status in Center of Technology for Maritime Industrial Engineering BPPT. The outline of my presentation is, the first is about BPPT and Technology Center for Maritime Industrial Engineering. Second, I will talk about the Indonesian Hydrodynamic Laboratory main activities. Next, I would like to introduce the present research agenda, and the last, I will discuss possibility to make collaboration research that need an engagement from other institutions. This is a BPPT organizational structures. Under BPPT chairman, there are 5 deputies: deputy for technology policy assessment, deputy for natural resource development technology, deputy for agro-industrial technology and biotechnology, and the 4th deputy for information, energy, and material technology, and the last, our deputy is deputy for industrial technology, design, and engineering. Under deputies, there are many technology centers. Besides technology centers, BPPT have also various industrial laboratories that not written here. The Technology Center for Maritime Industrial Engineering is under Deputy for Industrial Technology, Design, and Engineering. There are 2 laboratories in the center: Laboratory of Technology for Port Infrastructure and Coastal Dynamics, and Laboratory Hydrodynamic Technology. For marine affair, we also have cooperation with other laboratories when we develop tsunami early warning system and ocean renewable energy. That is Center for Marine Survey and also Center for Energy Technology. BPPT has special unit to conduct research collaboration or give technology services with other partners from private sector, industries, and services. The unit is BPPT Engineering. However, for the laboratory service, the customer can directly sign contract with the related laboratories. This is our Center of Technology for Maritime Industrial Engineering. The Center of Technology for Maritime Industrial Engineering is located in head office in Jakarta. However, the laboratories are outside in Jakarta. That is the Laboratory of Technology, Port Infrastructure, and Coastal Dynamic. We call it BTIP-DP in Yogyakarta, and my laboratory, that is Laboratory for Hydrodynamic Technology, is well known as Indonesian Hydrodynamic Laboratory in Surabaya. This is the Coastal Dynamic Laboratory in Yogyakarta. Their activities are port design, physical hydrodynamic, tests about coastal dynamic like wave breaker, sedimentation, tsunami, breakwater, and so on. In the laboratory, they have tank or basin for 3-dimensional testing, especially for tsunami, physical model for tsunami wave, and wave flume for 2-dimensional tests. They also make many numerical analysis for coastal dynamic problem. Their ultimate achievement is the ocean wave breaker named BPPT Log that already patented and used for applied in several beaches in port in Indonesia. My laboratory, Indonesian Hydrodynamic Laboratory in Surabaya, it's called Balai Teknologi Hidrodinamika or Laboratory of Hydrodynamic Technology. It's located in 10 November Institute of Technology or ITS. This laboratory is the biggest one in the Southeast Asia and consists of 3 main facilities. Those are the towing tank, maneuvering an ocean basin, and cavitation tunnel. I would like to explain the main activities in Indonesian Hydrodynamic Laboratory. This is the aerial view of our Indonesian Hydrodynamic Laboratory by Google Maps. The laboratory area is about 7 hectares. We give many services for the customer, especially from shipyard industries and oil and gas companies. When the customer come to us, usually they provided drawing, like lines plan, kind of hydraulic testing, and so on. We make then a new drawing, it is scale drawing, and send this to ship model workshop and the mechanical workshop. There are made physical model, ship model and mechanical model like propeller, stern tube, and so on. When the model is ready, it will be checked by quality control, because we already use ITT standard and ISO 17025 standard for hydrodynamic testing. After that, the ship model will send to hydrodynamic facility like towing tank, maneuvering, and ocean basin or cavitation tunnel. This is our towing tank. The dimension of the towing tank, the length is 235 meters, the width is 11 meters, and the water depth is 5.5 meters. It equipped with carriage and wave generator. The maximum speed of carriage is 9 meters per second, and maximum wave height is 70 centimeters. The service of this facility is for ship power prediction, wave pattern analysis and flow, visualization test, propeller open water test, engine matching solution, unconventional propulsion system model test, and numerical computation. We also use a statistical power prediction. This is our maneuvering on ocean engineering basin called the MOB. The basin dimension consists of two basins. It calls deep water basin. The length is 60 meters, the width is 35 meters, and the water depth is 2.5 meters. But in the middle of the deep water basin, there are pits with the size is 5 times 5 meters for horizontal and 9.5 meters for water depth. Another basin is shallow water. The length is 45 meters, the width is 35 meters, and the water depth is 1.25 meters. Equipped with wave generator. There is a longitudinal side of wave generator and transverse side of wave generator. It can generate regular wave, irregular wave, oblique wave, and also we have a carried that speed 2 meters per second that can move longitudinal and lateral direction. The service for maneuvering on offshore engineering basin is offshore design appraisal, offshore hydrodynamic experiment, mooring design and analysis, shipkeeping quality investigation and model test, maneuvering quality assessment and simulation, numerical computation, and ship motion analysis, time domain, mooring analysis, and ship maneuverability prediction. We also involved with the development of floating LNG of Impact Masela project and also Chevron project for floating production unit. This is our cavitation tunnel. The services cavitation phenomena prediction, measurement of propeller excited hull vibration, numerical computation, that is prediction for unsteady propeller cavitation. The testing size is 0.85 times 0.85, and the length is 4 meters. The maximum speed of the water is 9 meters per second, and maximum pressure is 2 bar. Besides giving service, we have our own research. I would like to share our present research agenda. The first research is concerning with designing harbor tugboat that have dual fuel for the engine using conventional fuel and LNG. The research is national research priority. We collaborated with several institutions like ITS, Surabaya 10 November Institute of Technology, Classification Bureau, and the biggest shipyard in Indonesia, PT PAL, and also PT Pelindo MARIN. Next year, together with ITS, we have to finish the design of LNG storage, regasification unit, and also the converter kit. The target for 2024 approval designed by Classification Bureau for the harbor tug prototype of regasification unit is certified by the regulator, and converter kit system which is optimized for harbor tug engine. The other research is designing mini LNG carrier, especially for Eastern Indonesia. This is also national research priority. Next year, we will finish the design of LNG ISO tank container for 20 and 40 feet. And with ITS, we conducting feasibility study for the route of the LNG carrier in Eastern Indonesia. And then BPPT will manufacture the prototype of air supply regulator. We hope in 2024, the ship get design approval from Classification Bureau, and the prototype of ISO tank and air supply regulator will be certified by regulator. Now the project is design special purpose ship for decommissioning and removal of offshore platform. You know, in Indonesia, there are more than 400 old offshore platform. It is already operated more than 30 years. The government wanted to remove the platform, so that we got assignment to design the offshore platform removal ship. We hope next year we will get design approval from Classification Bureau. Another research that we make many research about ocean renewable energy converter like wave and marine current turbine. This is the photo when we conducted designing, testing, and prototyping with energy converter. This prototype of oscillation water column was installed in Baron Beach in Yogyakarta. We also made research the combination of wave and marine energy converter called wave current rotor turbine, and already test in South Malang Beach. The famous one of our research is marine current turbine that installed in Larantuka Strait. Larantuka Strait is situated between Flores Island and Andonowati Island. Because of this research, Larantuka Strait right now is famous in the world. Many ocean renewable energy technology provider and investor wants to install their marine current turbine. The investor that get permission to install marine current turbine, that is a consortium of tidal bridge from the Netherlands. You can see the video of the test of our marine current turbine in YouTube channel, in my YouTube channel. So this is my last slide, possible collaboration research. Starting from this year, BPPT got assignment from Indonesian government to install 32 tsunami early warning system. It will be installed in Indian Ocean and Pacific Ocean. We already designed the conventional tsunami early warning system that is buoy type. There are two components of buoy tsunami early warning system. That is buoy that float on the surface and ocean bottom unit integrated to the sinker. The two components is connected with mooring system. We made numerical simulation of deploying process of the sinker of the ocean bottom unit. This is the simulation animation for deploying process of ocean bottom unit. The purpose of numerical simulation is to predict the velocity of the sinker when submerged about 2,000 meters underwater surface. The allowable velocity is around 1 meter per second when sinker arrive at the bottom of the sea. Another numerical simulation is the behavior of buoy when facing wave load and predict the load at the mooring line system. The conventional buoy system is quite expensive, so we have an idea to change the buoy system with wave glider. Through wave glider, we don't need ocean bottom unit and mooring system. Wave glider will move freely at certain limited area and collected the motion of water column, which is affected by earthquake, and send signal to the satellite directly. There are two components of wave glider, the floater and the wave glider itself. The movement of wave glider is merely from the response and relative motion of the floater in the wavy water. The pitch and the heave motion of the floater will generate motion to the several foil in the wave glider. The flapping motion of foil will produce the surge motion and tow the floater forward direction. This is the simulation of the response of floater due to the wave and affected the motion of single foil. The research is still in early stage. We need collaboration with other institutions, especially designing the flapping foil system of wave glider. For example, to determine of the pivot position of flapping foil. The pivot where the foil rotated gave a great impact to the force produced by the foil. Other research aspect is umbilical component that connected floater and wave glider, and also rudder component in order the wave glider can maneuver freely. We hope there are collaboration research to support the new system of tsunami early warning system. That's all my presentation. Thank you for your kind attention. And we hope there are collaborative research with you. Bye-bye.
Dr. Tim Bunnik will present the third lecture entitled Maritime Research Institute Netherlands, an Introduction and Ideas for Collaboration. Please enjoy.
Hello everybody, my name is Tim Bunnik. I'm working as a researcher for MARIN, the Maritime Research Institute in the Netherlands. I would like to thank the organizers of this event for giving me the opportunity to present MARIN, talk about research activities, and present ideas for possible collaboration in the future. The title of the presentation today is therefore as follows: Maritime Research Institute Netherlands, an Introduction and Ideas for Collaboration. The contents of the presentation are as follows. First, I will show an introduction to MARIN and her activities. Then I will talk about the future of ocean energy and shipping. Then I will give some specific project examples related to our recent blue growth activities, the sustainable use of the ocean. I will talk about floating islands. I will talk about floating solar systems, and I will talk about floating infrastructure. First, I will show a video with an introduction of MARIN given by our president, Bas Burgner.
MARIN is een onderzoeksinstituut wat schepen probeert schoner, slimmer en veiliger te maken. Dat doen we met waterbakken zoals deze, waarin we schepen testen. Dat doen we met rekenwerk, we hebben een grote supercomputer. En we hebben een brugsimulator waarin je op een echt schip de haven van Rotterdam of Rio kunt binnenvaren. MARIN staat voor schepen met mindere emissies over het water te vervoeren. MARIN staat voor meer veiligheid op zee. En we staan ook innovatief met de Nederlandse maritieme sector, zodat die ook wereldwijd nog steeds voorop kan blijven lopen. We zijn naast de grote instituten van de marine van Rusland en van Amerika het grootste onafhankelijke instituut. Dus we zijn onafhankelijk, we zijn geen overheidsinstelling. We kunnen onze mening geven over alles wat we tegenkomen. We worden gevraagd door reders, door scheepsbouwers, ingenieursbureaus, maar ook de overheid. De Koninklijke Marine is een belangrijke klant van ons. Klanten bij MARIN die komen met hun tekeningen, die brengen ze hier. Daar maken wij schepen van op schaal. Die leggen we in zo'n waterbak. Daar stoppen we allerlei meetapparatuur in. Die meten we, analyseren we en uiteindelijk, dat is het belangrijkste, we geven een antwoord op de vraag. Nou, uiteindelijk, we zeggen altijd, the proof of the pudding is in the eating. Als er een probleem is bijvoorbeeld, iets trilt, maakt geluid, buigt te veel door, gaan dan meten, gaan een hele reis mee, komen dan uiteindelijk terug met de meetresultaten. Die worden geanalyseerd en uiteindelijk het belangrijkste is het antwoord op de vraag. We zitten ondertussen op 375 mensen die allemaal bezig zijn met het ontwikkelen van kennis, het toepassen van kennis en het delen van kennis. En dat is het bijzondere. Dat doen we 80 jaar. We zijn begonnen in die waterbakken en dat zal ook nog jaren blijven. Maar dat wordt nu steeds meer virtual reality. En het aardige is dat je dat via internet kunt delen met iedereen op deze aarde. En dat gaan we doen om schepen schoner, slimmer en veiliger te maken.
After this introduction by our president, I would like to show you MARIN's view on the future of ocean energy and shipping.
The future of ocean energy and shipping. At any given moment, tens of thousands of ships are sailing the world's oceans and rivers, carrying about 90% of total world trade. Transport and energy production rely mainly on fossil fuels. Oil, gas, and coal account for more than 80% of our entire energy supply. Although fossil fuels have been an incredible driver for development, they also represent a major threat to the climate. We have to develop renewable energy supplies if we want the planet to remain habitable. We believe that the oceans, which cover more than 2/3 of our planet's surface, will be the key to a sustainable future. Zero-emission shipping is the only way forward. This can be achieved by more efficient vessel design, as well as by the use of wind and other renewable energy sources. While hydrodynamic techniques in ship design have led to optimum performance, the integration of energy supply and propulsion systems will bring us even further towards zero emissions. Zero emission will only be achieved by developing renewable fuels as an alternative to fossil fuels. Shipping could be energy neutral by 2050 if we power ships with wind and solar-generated electricity. The wind and the sun represent a massive source of renewable energy, which is more abundant at sea than on land. Harvesting this energy will require offshore wind parks and floating solar panels, as well as wave energy converters, tidal turbines, and ocean thermal energy conversion. Processes are being developed to store the vast amount of renewable energy efficiently, in the form of hydrogen, liquid methane, or ammonia, for example. The availability of this technology offshore will be a game changer for shipping and harbors, creating entirely new maritime infrastructures. large-scale wind and solar-powered energy and transshipment hubs will be located along major shipping routes. These energy islands could be used for renewable energy conversion and storage, but also as logistics islands, where cargo could be transferred from larger to smaller ships. The shift to ocean energy hubs will not only support next-generation shipping, but will also open up the possibility of floating settlements. This imminent revolution demands that we rethink the way we engage with our blue planet. We must redesign ocean transport as well as tomorrow's energy. MARIN. Better ships, blue oceans.
So now I would like to talk a little bit more about MARIN's activities related to blue growth. Blue growth is the long-term strategy to support sustainable growth in the marine and maritime sectors as a whole. This is a topic that is strongly supported both by the European Union and the Dutch government, and MARIN's activities related to blue growth over the last 5 years have increased considerably. Therefore, I would like to show a few examples of our blue growth activities. One of them is the concept development to show the potential of floating islands. In the movie on the future of ocean energy and shipping, you have already seen a few examples, and I would like to show a few more details. So these floating islands can be used for multiple purposes. One example is to use them as energy islands, where they can be used for maintenance, for example, maintenance of offshore wind turbines, but also for the transport and storage, for example, of hydrogen in the future. But also climate adaptation could be floating. It may happen in the future if we cannot stop climate change, that parts of the Netherlands will be flooded, like you see here. That means that we need other spaces to live, and that could be by means of floating cities. A few years ago, we started a European project, Space at Sea, with the objective to provide sustainable and affordable workspace at sea by developing standardized and cost-efficient modular islands with low ecological impact. In the video, you see the model tests that we carried out for this modular island in our offshore basin. You see that the concept consists of triangular modules, which can easily be connected and disconnected and used for multiple purposes, like I said, for energy storage or even living at sea. At the moment, this European project is being finalized. These modular islands, it's quite challenging to perform numerical simulations, and that's just because of the sheer size of these islands, which can be several square kilometers. Even our most simple numerical models, that's based on linear theory, have quite a lot of difficulties to do computations for these concepts. Like I said, just due to the sheer size. But here you see an example where we modeled the island. You see it's sort of a diamond shape in our linear diffraction tools. And you can compute along the length of the island what the pressure is due to the waves. You see the pressure on the left due to the undisturbed wave system. Then the pressure distribution that occurs due to wave diffraction. That's basically the reflection of the waves on the island. And the sum of the two is the total excitation pressure on the island. So really that the forcing, the loading that the island feels. And because of this loading, the island starts to move. And then on the right, you see the vertical motion of the island at one specific wave period. So these computations can be done, but you really need a computer cluster like we have available at MARIN to perform these kind of simulations, even with a linear tool. Another example that I want to show is the work that we did on submerged tunnels. And I will show a video on this topic.
I think a transatlantic hyperloop can be an interesting option for fast passenger transport across the Atlantic in a sustainable way as an alternative for polluting airplanes.
In the Hyperloop, we transport pods that are around 30 meters in length and house about 60 people. So compared to a high-speed rail, that would be very small, but we do that to increase our frequency.
This test is to identify the motions of the tunnel due to waves. So waves are running on top of the ocean and the tunnel is going to move a bit. And the question is, how much is it going to move? And are these motions small enough for the train to pass through smoothly?
The model is 140 meters long, which is equivalent to a tunnel of 15 kilometers. The middle of this part responds the same as the long tube, which is over 5,000 kilometers.
MARIN is a unique place. We have unique facilities. This basin you see behind me here is 170 meters long. So because we needed a model of 140 meters, this is one of the few places in the world where you can do this, especially because we also want to make waves and see how the tunnel responds in waves. The first step is, once the model goes out of the basin, is to fully understand what happened. So we're going to analyze all the results and hopefully build a consortium to further develop the concept of mid-water floating tunnels.
The last example that I would like to show is related to floating solar systems. These are already developed for sheltered areas, lakes, like the one shown here on this picture, which is a floating solar system in the Zwolle area in the Netherlands. I think it's one of the biggest floating solar systems that exist at the moment. But of course, there's only limited space for that. And therefore, we are also involved in developing concepts for harsh ocean environments, because there the space is almost unlimited. This is a video of a project that we did together with an innovative company, Sunfloat, that has developed a prototype for such a system.
Every development which we can do in the combination between energy and water, for me, it's the right option.
MARIN we try to make ships cleaner, safer and smarter, and to contribute to a sustainable use of the seas. We also want to work with small companies, innovative companies like Sunfloat, and the idea is that they have the idea and we show them how it works in reality at sea, but also how we can improve it. So our project managers think with the client to improve the concept based on our knowledge.
I really believe in floating solar. There is so much space which we can use, and 2/3 of the earth is water. So when we harvest energy, we should harvest it on the water. So we already have a product. And from that product, we can reason backwards what is the better product or the best product. And therefore we need the expertise of MARIN because they really can understand what the physics behind this products are. And from that one, we can develop the new version of this product.
We have been working in floating oil and gas for many decades. We have been working on floating wind for the last decade, and we are really starting with floating solar now. So for us, it is very interesting to be involved. Beforehand, we made numerical predictions of the motion behavior, and we are very curious to learn from this model test how valid it is. We measure the produced waves at the location of the model. We measure the motion response of the model, do it to the incoming wave, and then impose that same wave in the numerical simulation. And then if we get the same motion response of the platform in the basin as well as in the simulation, then the numerical model is validated. In a numerical model, you can vary all kinds of parameters, and that gives you the ability to use it as a design tool. So if you want to design for specific conditions, it's quite easy to vary all those parameters and come to an optimal design.
Working with MARIN is great fun. That's because you meet a lot of very passionate, experienced people with great knowledge in this area. And that in combination, where we also work together with ACN, which is the energy center in the Netherlands. And this combination of two pools of people who really know a lot about their own field makes innovation really fun to do.
So this concept is based on a rigid support structure that supports these solar panels. We have also been involved in the development of concepts which are based on a flexible support structure. So that then consists of a encapsulated PV module together with a carrier foil that is supported by a floater material, some kind of mattress, foam mattress, for example, that prevents the solar panels from sinking. The challenge here, of course, is that the material can deform due to wave action, and the deformations should not become too big in order not to damage the solar panels. We are performing numerical simulations for these modules, model tests, but also full-scale testing to see the behavior in waves, and if this really a feasible concept, also really for the harsh environment, for example, that you can see in the North Sea. So this is a video showing the deformations of the PV module due to wave action. We are validating that by means of model tests that we're going to perform. And on the right, you see a picture also of a PV module, a slightly different concept that we have put in a lake in the Netherlands to see what the behavior is. This is the end of my presentation. I would like to thank you very much for listening and viewing this video. Of course, MARIN is always open for collaboration on any maritime topic. And if you want that, do not hesitate to contact us at www.marin.nl. Thank you very much, and maybe we see each other in the future.
For lecture 4, we go back to Surabaya to Professor Dr. Ketut Buda Artana. He is from the university, from Instituut Technologie Surabaya, and will talk about a recent approach on the safety assessment of marine installation.
Good morning, everyone. I'm Ketut Buda Artana from the Center of Excellence of Maritime Safety and Marine Installation of ITS Surabaya. I'm very much honored to be provided with the chance by LabMath-Indonesia for this lecture. Today's lecture is about a recent approach on safety assessment of marine installations. This lecture is going to be based on my experience as professors in Department of Marine Engineering of ITS, as well as 20 years of experience in assisting oil and gas company in maintaining the safety operation of their facility. Allow me to provide you with the slide of my presentation. I've been working for ITS Surabaya, one of leading university in Indonesia, since 30 years ago. I have about 20 years experience in assisting some leading oil and gas company, as well as LNG terminal operators throughout Indonesia, especially in their effort to maintaining the safety operation of their facility. Last year, I concluded my assignment as the Vice President for Research, Innovation, and Internationalization of the university. Since then, I back to my laboratory, and with my colleagues and students, we developed an early warning system to maintain the safety operation of offshore facilities and vessels. Now the devices has been utilized by some major oil and gas industry in Indonesia. First of all, allow me to briefly introduce my institution. ITS is one of leading university in Indonesia. We are located in Surabaya. We are established in 1960. And we have around 20,000 students, 1,000 academic staff. And we have about 180 laboratories, 10 research centers, and 4 centers of excellence. One of the center of excellence is my laboratory, which is the Center of Excellence for Maritime Safety and Marine Installation. According to the Ministry of Transportation Decree number 129, the year of 2016, this ministry decree regulates the shipping channel and marine installation. And the term marine installation is dedicated to all facilities located and operated offshore, comprises of offshore structure, subsea pipeline, subsea cable, and also overhead cable. This regulation is aimed to protect the safety of ships when they operate in a position close to marine installation, and of course, to protect the facility itself. Why the government need to regulate this matter? It is very obvious that the existence of this facility will provide hazard to the marine traffic or vice versa. With those examples of possible hazard, it is very clear that the government need to regulate to protect not only the facility, but also the people and the environment. Shall we have a look? Some incident that happened in Indonesia around 2 or 3 years ago. This figure shows the incident that happened in East Kalimantan. Ship anchor damaged the crude oil pipeline and ended up with people casualties and serious environmental problems. This picture shows a gas pipeline located near Jakarta, hit by ship's anchor during the ship performing sea trial tests. The pressurized gas bubbling out to see water. And we could imagine the problem that might happen if that gas was ignited. And the last picture shows the condition of one offshore platform located in Madura Strait, very close to our university, after collided with a big vessel. More than $100 million spent by the company to fix the damage. The next question is how we could ensure the safety of this facility. One well-used method is called risk assessment, in which potential loss is measured by incorporating the frequency of incidents and its consequence. Risk assessment is a generic sequences of measuring the potential loss due to hazard that might happen to a system. In this particular cases is in marine installation. The safety condition of a facility is obtained when the risk is acceptable. Acceptability to the risk is very much depend on the frequency of the hazard and its consequence. The frequency is measured in the unit of incident per year, and the consequence is measured in the unit of effect of the incident, of each incident. A standard is referred to verify whether the risk is acceptable or not. If the risk is acceptable, then the system is okay. If the risk is not acceptable, then the effort is need to be taken to perform either to avoid the risk, to mitigate the risk, or to transfer the risk. Some methods has been well developed and established in every sequence of the risk assessment, as we can see in the right part of this slide. This figure shows the example of risk matrix and event curve, two generic ways of representing the risk. When those levels end up to acceptable level, the green area, then nothing to be carried forward. But when the risk lies on the unacceptable level in the red area, then mitigation takes place by either reducing the frequency of hazard or by reducing the consequence. On the other hand, the event curve, as we can see on the right picture, is represented by a logarithmic scale chart, used usually when the risk related to fatalities. The horizontal axis shows the number of fatalities, and the vertical axis shows the frequency of the incidents. Ladies and gentlemen, now after understanding the generic process of the risk assessment, shall we have a look how we implement the process of assessing the risk in real situation. At first, I will introduce a case that we had in some years ago, in which an offshore platform was going to be installed very close to a shipping channel. The hazard of ship collision with the platform was very obvious, as we can see from this slide. This picture shows the navigational chart of the entry point to Madura Strait, where a very big port, we call it Port of Tanjung Perak, is located. One of state-owned oil and gas company planned to install an unmanned offshore platform with a distance of 500 meters from the center of the channel. As we can see here, a small dot here, this is the location of the platform, the offshore platform. If we enlarge the picture, then we can see here that PHE7 is the code for the offshore platform to be installed. The location was very close to the center of the shipping channel. There are some navigational buoys here. This is buoy number 0, this is buoy number 1, and this is buoy number 3. Since the distance between the center of the channel is very close to the design coordinate of the offshore platform, then a collision risk assessment of vessels to the platform must take place. A risk is acceptable when the collision the frequency of the collisions is less than unity. The result of the analysis can be seen in this slide, in which the design position of the platform will be implied with the collision frequency of more than unity, both in good feasibility or bad feasibility. As we can see here, so with the design position of the platform and the distribution of the vessel passing the channel, then we can see that in the good feasibility, the collision frequency will be as we can see in this figure. And during the bad feasibility, we can see that at maximum, there are 8 vessels will collide with sorry, the platform. Then the right picture shows how we mitigate the situation. The way to mitigate the situation is by shifting away the buoy number 0 to the west side of the channel at a distance of around 9 kilometers. By doing so, then the distance between the platform and the center of the channel will be also longer, sorry, wider. And we can see as the result, then we can reduce the collision frequency from 8 collision per year into only 0.9 collision per year, which is almost less than unity. A further investigation can be performed to find the best design of locating the buoy. At the same time, we need also to consider the best way of ship navigating through the channel. And after all process can be verified, then we can decide the coordinate of each buoy that will ensure that the collision frequency within a year is less than unity. Next, I would like also to introduce to you one case study on subsea pipeline risk assessment, which is using a different approach compared to the previous one. This table shows all possible hazards that might happen to a subsea pipeline. That Norske Veritas and GL, Germanische Lloyds, RPF 107 has been recommended some possible hazard, as we can see on this table. These all possible hazards need to be considered when we measure a risk of the subsea pipeline to be installed under the water. And energy balance can be utilized to measure the consequence when an anchor ships drop to the pipeline. Once we found this table shows the frequency level and the consequence level according to the standard. As we can see here, that the frequency level is divided into 5 levels, so as the consequence level. One, we found the denting diameter and the frequency of the drop anchor, drag anchor of ship sinking to the pipeline. Then we could find the recapitulation of the frequency level. As we can see from this slide, that all frequency level lies in number 1, since the collision frequency is less than 10 to the minus 5. This table shows the summary of the consequence analysis, in which vessel passing the channel is classified into the size of the vessel, because the size of the vessel means the different size of the anchor. As we can see here, for the small vessel, the denting per diameter is less than 5%, which is lies in frequency number 1. But for big vessels having the big anchor, then the denting diameter will be more than 20%, which is mean that the pipeline is ruptured. By correlating the frequency analysis and the consequence analysis, then finally we can see here through the risk matrix, then the risk of hazard of drop anchor would be acceptable for the ship sinking will be as low as reasonably practicable, and then, for the drag anchor will be as low as reasonably practicable, and for the ship sinkings will also be in acceptable level. And then how we could implement the risk assessment method in designing the safety of the LNG terminal. According to our experience, it just happened last year. We are requested by a port company to assess the safety of a floating LNG terminal located in Surabaya. As we can see here, this is the position of floating storage unit of the LNG for the LNG, and this is the position of the shuttle vessels. But across the jetty, there will be a bulk carrier terminal. So we need to ensure whether the position or the existence of this LNG terminal will give impact to the environment, especially the loading and unloading operation of the bulk carrier. So again, frequency analysis is performed to assess the possibility of leakage of the LNG, and then if it's ignited, then will be we measure the possibility of incident of flash fire, pool fire, jet fire, or even the vapor cloud explosion. And at the same time, we also perform the consequence analysis by using the fire modeling method. Then we can see here the estimate casualties when jet fire, pool fire, vapor cloud explosion is happened to the facility. And the risk is represented by using event curve. We can see here that for the jet fire of leak hole diameter, then we can see that the risk is located in the as low as reasonably practicable level. But for the vapor cloud explosion, then there is a possibility of the risk shifting from the alarm area to the unacceptable level. Then mitigation must be taken to make sure that there is no condition where the risk is located in unacceptable region. For your information, in our centers, we also do quite many studies on LNG distribution. Because as you may well understood that our current government have a big plan to distributing clean energy in which the LNG and natural gas to the many areas in Indonesia, especially in the eastern part of Indonesia. Then our Center of Excellence has been for more than 20 years doing research on LNG supply chain, and then safety assessment of LNG and ship terminal, non-conventional LNG ship design, and then route optimization of LNG vessel, including the system of LNG vessel, LNG ships and terminal, and design of LNG terminals. We've been provided with opportunity in designing LNG distribution in eastern part of Indonesia with the cooperation of British Petroleum and SKK Migas, and we also been provided with opportunity to design the LNG distribution in the central part of Indonesia with the cooperation with National State-owned Enterprise of Gas Distribution, PGN, and the electricity company. This picture shows our counterpart, our partner in performing quite many studies on the LNG distribution. Ladies and gentlemen, as I've been mentioned to you previously, that our center also developed an early warning system to maintain the safety operation of offshore facilities. We call it AIS-ITS, which is the abbreviation of Automatic Identification System of ITS Surabaya. We have website application as well as the mobile applications. This application can be utilized to ensure the safety of the marine installations, covers the offshore platform, underwater pipeline, underwater cables, and we could also utilize this application for ship management at port, ship tracking, fuel monitoring, and then monitoring of the potential ship exhaust emission and ship inspection our colleagues in our center, we have quite many professors graduated from quite many universities, work together to develop the application, and we have also the development team. The basic of the application, the platform of our application can be seen in this slide. So we install quite many automatic identification system developed in our center in many places. We obtain the data, and then we record all the data into our server, and then we implement quite many algorithms. And one of the algorithm we develop is to be used as the early warning system to maintain the safety of pipeline, the platform, and the ship itself. So we've been installed quite many devices in the northern part of Java Island. With this facility, now we can cover Java Sea. We can cover all ships real-timely located in Java Sea. We also install some equipment in Kalimantan. So as we can see here, we has also been received quite many data of the ships operating in the area. As also been mentioned to you, we work with a private company, and through this cooperation, now we operate one office in Jakarta. We have a sophisticated data center, monitoring room, and also we still working with our student here in our university to develop quite many applications based on the data we obtain from the devices. This picture shows our student who developed startup in providing early warning system for major oil and gas industry in Kalimantan. And the devices also been utilized by the government to design a traffic separation scheme for two main streets in Indonesia, which is the Sunda Street and Lombok Street. And this picture shows one of our colleagues, Dr. Made Ariana, alongside with the official representative of Indonesia, doing presentation in IMO London in maritime safety councils in the effort of our government to get permit designing these two main streets, which is Sunda Street and Lombok Street, as the street that implement the traffic separation scheme. I think that's all my presentation to you. Then I hope that opportunity to have cooperation with you all can be obtained through this program. Thank you very much for LabMath for providing opportunity to me to share some research activities and projects we perform in our center. And hopefully we could follow up all of cooperation between us. Thank you very much, then.
The final lecture in this series, lecture number 5, is about our institute LabMath-Indonesia, the software, and is presented by Dr. Andonowati, the director of LabMath-Indonesia. The precise title is Hawaii Simulations for Ocean Engineering.
Welcome to my presentation. My name is Andonowati. I'm from LabMath-Indonesia, an independent research institute located in Bandung. My presentation is about Hawaii, our software, and the simulation for ocean engineering. To start my presentation, I'm going to take you to a tour in the Atlantic Ocean. You can see here very high wave with the high energy, somehow beautiful, but somehow frightening. Such high wave can happen during stormy days. This type of wave can also appear in solar sea, and we design such a sea and we call it a Dropner sea. Why we call a Dropner sea? Because in the New Year's 1995, from a Draupner platform, a camera capture 18-meter wave in the North Sea. And such wave is much higher than the wave surrounding. To be able to simulate such a high wave, we are using meteor data from the surrounding Draupner platform. And here is the meteor data and the spectrum. We add a random phase and we reconstruct the sea surrounding the Draupner platform. As you can see here, you have 3 successive freak waves at the different location from this reconstructed sea from the meteor data. Actually, such high wave is very dangerous for the ship. And so we also take a look at the statistic and see that the wave exceeding 18 meters occur in average in 20 minutes over an area of 1 kilometer square. So recently we add a module which is a radar reconstruction that can see a wave far away and predict the wave close to the ship at the 2 minutes ahead of the real time. So what is the principle of this radar observation? First of all, this radar shoot or send electromagnetic wave, and this wave is partly reflected by the water surface. As you can see here, that the lower wave is being blocked by higher wave. And so we see these shadow images. And then from these shadow images, using our software, we reconstructed the whole sea, including the area that is the location of the radar. As the radar can look far ahead from the location of the radar and the ship, we can predict what will happen, the type of wave that will arrive in the ship 2 minutes ahead of the real time. Now, as I mentioned before, that the very high wave is very dangerous for a ship. So we go to the TU Delft lab and the MARIN lab to see whether our simulation can predict such high wave. So in doing so, we wanted to generate wave at the 50 meters from the wave maker. Such generation of a high wave is also very important to test the ship in the lab. So to be able to design this high wave at the desired location, we use our software to do a backward simulation and to obtain the wave or the signal located at the wave maker. This signal then become an input for motion of the wave maker. So as you can see here that the short wave followed by longer wave and then collide at the desired location to create the very high wave. Our simulation matches very well with the experimental data at several locations. Now we go to the design of a harbor with access channel that is done through the experiment at the delta rest. Here, the harbor will be designed on the surrounding area that has a shallow area. And to be able for the ship to enter the harbor, part of the area has to be dredged to create a channel. So here the channel has a depth of 21, while surrounding area, which is shallower, has the depth of 11 meters. So we are testing our software to see whether we can simulate the wave in such a difficult bathymetry. So the input of the simulation is irregular, multi-directional, that has a Johnson spectrum. From this area, you can see here a very complicated simulation in such a way that some wave breaking and entering the channel and some other is reflected from this area. We also compare our simulation with other simulation using existing software, for example, MIC, SWAN, and SWOS, where their bias against the result of the experiment at the 9-point measurement is quite high, while our bias, the average bias, is only 0.27%. And this is the standard deviation from the bias here. Now we go to the next presentation, the location, which is quite familiar with the Indonesian audience. And in this tour, actually, we are presenting a position in such a way that that is safest for floating storage regasification unit to be positioned at the river mouth. So we take a look at the bathymetry surrounding the area. This is the bathymetry, which is between 5 to 20 meter depth. And floating storage regasification unit has to be positioned at the river mouth to the harbor. The position has to be the safest in such a way it should prevent from the resonance from the infragravity wave. To be able to simulate in such a location, we use the wind field that we obtain from the ocean surrounding Cilacap, and using SWAN, we calculate the spectrum. With this spectra, we input into our software, and here is the simulation using our software. And we filter only to obtain the infragravity wave. And from here, we can see that this is the location in such a way the position is the safest, that in fact gravity wave doesn't impact the location. Now the last presentation is about a test at the lab of Marseille. This is the actual lab setting. Here, a floating generator is located in a deeper area. A ship is positioned in the sloping bottom. The wave is moving from the deeper area going to the sloping bottom. We are requested, we are look at the several positions at the sloping bottom, and we try to compare our simulation with the measurement from the deep into a shallow area. Our simulation corresponding very well, 90% with the measurement, and in fact, the significant height corresponding very well with the measurement. So here is our simulation for the sway, heave, and roll motion. And here is the location of the ship. And we try to compare with the theory, measurement, and our simulation. Here for this type of wave with significant wave height, 6 meters, and the peak period, 12, and at the depth of 21, Liu mentioned that the standard deviation for the sway is 15.6, which is actually twice as large as the measured also by Liu. While our Hawassi simulation result very close to the measured experiment. This is the last of our technical presentation. Now I'm going to explain about this Hawassi. What is Hawassi software? This Hawassi has been developed within our institute over 10 years. It stems from HA, which is Hamiltonian structure of the dynamic equation. WA, which is a wave, can be linear, second order, third order non-linearity. It has exact energy conservation. Kinematic braking and potent friction has been added. We use pseudo spectral implementation in such a way that the simulation is very fast. We implement varying bottom as well as with refraction and diffraction. SSI stands for shape structure interaction. For example, we already saw you the reflection from the harbor wall as well as brick water. Recently, we add a shape module with all possibility of wave simulation, whether it's moored or free. And we also use the new dynamic equation that deal the diffraction at each time step. Recently, we also add the radar module that I already explained to you previously. We the Hawasi is available in the MATLAB and C version with full bidirectional coupling with CFD. Now, the last sheet here, I would like to talk about our institute. LabMath-Indonesia, which is Laboratorium Matematika Indonesia, is an institute that we founded in 2005. This institute is under the foundation. We focus on the multidisciplinary research using mathematical modeling and simulation. We hosted a Ph.D. and MSc student as well as scientists. We also conduct workshops and courses. Recently, we created a new startup company which is called PT Bahari Percaya Indonesia. This startup received a RISPO project. We also have MOU with LIPI for staff exchange. We are doing a project with Technip FMC, and our software also licensed by Samsung Heavy Industry. Here is our staff member at the moment, and this one here is several institutes where we have been collaborating with. As I mentioned before, that Hawasi is developed and LabMath-Indonesia is the license holder for this software. So the last that I would like to mention to you that if you think you can collaborate with us and you think that we can work together, please do not hesitate to contact us at info@labmathindonesia.org. I would like to thank you for your participation in this presentation, and have a good day.
This finishes the series of 5 lectures on this topic of ocean engineering. I thank once again all the lecturers who put so much effort in preparing their presentation. Ibu Aan already talked about the other activities on ocean engineering, but after that there will be a similar activity on coastal engineering. And we will inform on websites and in other ways about the precise date, somewhere at the end of October, that activity will start. Thank you for having shown interest in this activity. Thank you very much.